Good morning, students. Sorry I couldn't be there today, but I did want to give you something so that you could be successful. So I'm going to do the entire assignment on this here presentation, and I'm going to give the answers at the end or throughout the presentation. But sometimes I'm going to say them, and other times I'm going to actually type them so that you can see them. On your paper, make sure you write all of these and turn them into folder number 4. Okay. Again, make sure you write all the answers down and turn them into folder number 4. Now, I know you saw the length of the video. If you don't want to watch this video, of course, you can do it by yourself at your table. Um, that's fine. But I wanted to give you support just in case you needed it. So it says, I can explain how the differences between convection, conduction, and radiation are used in the real world. TEAC 6.9a. Keep in mind, convection is anything to do with a current. If it's going in a circle, whether it's a sideways circle, a vertical circle, it is still convection. It's this idea of heat circulates. Okay, it's how your oven at home works. It's how it cooks food. It's how our air fryer cooks food, and it's also how we move, how air moves around the world, and how tectonic plates are moved, which are the plates that we sit, the land that we sit on. But you'll learn about that later on in science. Conduction is heat by contact, the transfer of heat by contact. And you see here, this water is boiling because it's in a pan that's touching a heating element. It's touching it and it allows it to raise the temperature or to transfer that thermal energy. That is conduction. And then radiation is the transfer of heat between things that are not touching. So I can go to a fire or I can go outside and feel the sun without literally touching the sun, okay? So it just transfers that energy without touching. So we should be able to explain how the differences between them and how they're used in the real world. If you're just paying attention, you saw I just did that for us. Also, don't forget that heat always transfers from an area of hot to an area of cold. So let's look at our assignment. It's 1 half page, 2 half pages, 3 half pages, and then there are 9 questions for you to write your answer out on. I'm going to read them to you. If you don't want to listen to me read, you can skip this part. But again, when you try to get to these answers down here, I'm not typing all of them. I'm going to say them, but I won't type all of them. The first question reads, how does conduction occur? Next one, what must happen in order for conduction to take place? Describe a situation when conduction occurs. What is radiation? Name 2 objects that give off radiation waves. How does radiation differ from conduction and convection? What is convection? What does the movement create? And describe a situation where convection, um, oop, sorry, when convection occurs. So to answer those problems, we're first going to need to read the passage. So it says heat moves in many ways. Heat can be moved by conduction. It is moved by convection. It is moved by radiation. Conduction moves from one solid to another solid. Objects must be touching for conduction to occur. Heat moves from a burner to the pan. This happens when you turn a stove on to heat up a pan. The heat in the pan then moves to the food you are cooking. The heat from the blanket moves to your body to warm you up when you cover up with an electric blanket. In both situations, there is contact, okay, between 2 objects. They're physically touching. That's what makes it conduction. Convection is the movement of heat through liquids or gases, or liquids and gases. The movement creates a current. One example of convection is when you boil water in a pot. The water starts to boil from the bottom, and the hot water moves up to the top. That's why you see the bubbles popping up the top. Then the cooler water is pushed down, okay, and a current of circulating water is formed. Another example is when a space heater is used to heat a room. The air near the heater is heated and it circulates the room. This causes the heat to transfer between the hot and cooler air. Radiation is the transfer of heat energy through waves. Heat energy is given off by the sun's rays. We can feel the heat energy given off by a campfire. Radiation only travels in waves. It differs from conduction and convection. This is because no contact or current is needed for the heat to transfer. The heat waves from radiation even travel through empty space. So I'm going to stop after that first page, go over here. It says, how does conduction occur? It told us on the first paragraph, or I mean the first page here. Conduction occurs from one solid to another. Objects must be touching for conduction to occur. So I would just put through two objects touching. Okay. Um, the next one's what must happen in order for conduction to take place. Well, if I go back over here, it says here that conduction. This happens when you turn a stove on to heat. When you turn a stove on to heat up a pan, the heat in the pan the then moves to the food you are cooking, and the heat from the blanket moves to your body to warm you up when you cover up with an electric blanket. In both situations, there is contact between two objects. Now, um, what must happen in order? Well, one object has to be hot or warmer. I'm gonna put hot, and then it transfers it to a cold object. And I'll make that a little smaller so that it fits. There you go. Describe a situation when conduction occurs. Well, in the example, it talks about boiling water. What is radiation? Well, hopefully you've noticed by now, but these are actually the exact same thing. Okay, one, two, and three are the same thing. I was hoping you'd get to this point and realize this. But what is radiation? Radiation is a transfer of heat energy through waves. So, right here, you could literally copy this sentence. Radiation is the transfer of heat energy through waves. Right there. And again, I'm not going to type all of them for you, but it's right there. Radiation is the heat transfer of heat energy through waves. Now it says name two objects that give off radiation waves. Well, an example of radiation includes the heat energy given off by the sun's rays. Due to radiation, we can feel the heat energy given off by a campfire. So it gives us the sun's rays and the campfire right there. So 4 and 5 are right there. Now it says, how does radiation differ from conduction and convection? Well, the answer that I think of is that nothing's touching. With convection, technically, you have heat currents moving, but you could argue that the water is touching the pan, which is touching the heating element. But with radiation, it's just traveling through empty space. Okay, the thing, it's not touching anything. So I would say nothing is touching. Nope. Nothing is touching with radiation. Now, what is convection? Convection is movement of heat through liquids and gases. What does the movement create? The movement creates a current. It tells you right there that the movement creates a current. Those are those circular things I keep telling you about, how they can travel vertically or horizontally. And it says, describe a situation when convection occurs. Well, it gives us an answer, but I want to challenge you to think of something else. But it tells us boiling water is a perfect example, okay? It tells us that another example is a space heater. When air heats the air, it rises to the top, and then cold air sinks to the bottom, and then rises to the top, sinks to the bottom. And that's also what a fan does horizontally. It creates convection currents. Okay, so the hot air at the top is spun around until it cools down and falls to the bottom, and then it heats back up and falls to the bottom and heats back up. That's convection current. But try to think of a situation where convection occurs that is not given in this passage. Okay, those are the answers, and that has gone through the whole assignment. Originally, I was going to have y'all cut this in half and do a project where one person has one page, one person has two, no, one person has three, but I decided not to do that. So hopefully you notice that all three pages are the same and you only had to read it once. And if you watch this video, I just gave you all the answers or I showed you where to go. Okay. On your other assignment here, okay, don't worry, I'm not that cruel. I wouldn't have left you 3 pages to read, 9 assignments, 9 questions to answer, and a color sheet. There's only 1 page, and then there's this 5 question color sheet. It says, look at the number in question, color that number area of the picture according to the color. So, for example, if you think the answer to number 1 is radiation, color all of the number 1s red. So, number 1 says hot cocoa is stirred with a metal spoon. Soon, the spoon begins to feel warm. This happens because of. So, if I got a hot pan, okay? In fact, here I'm at my house. Y'all like the Christmas tree? Hey, it's pretty sad, right? But if here's my wife's favorite cup, okay? If I have hot cocoa in here and I stir it with a metal spoon, let me grab a metal spoon. So here's my little spoon, and I'm stirring up my hot cocoa. But I start feeling the spoon is starting to get warm. Well, is that because of conduction, convection, or radiation? That's actually going to be because the spoon is touching the hot liquid, right? Yes, I stirred it up, but it's still actually touching the liquid. All right. So that's not going to be radiation because it's not traveling through nothing. So red is not possible. Convection talks about currents. Is that why the spoon? I know we spun it up, but is that why the spoon gets hot? No, of course it's because it's touching the hot liquid. It's transfer of hot to the cold spoon. That's what our correct answer will be. So number 1 is yellow, and I need to color all the number 1s yellow. So let's see if I can do that here. I believe, hopefully you can see this, that all the number 1s are going to need to be yellow. So I find all the number 1s, go through and make these yellow. Now, of course, you need to make yours look pretty, okay? I'm just doing a quick example because you'll be here for like 40 years if I sit up here and make it look real. Now, ladies and gents, I need you to be so good to our sub. I believe it's Mr. Lopez and Miss, of course, the other teachers, Miss Lamel and Miss Sarta and Mr. Stumpf. And if there's anybody else in that room, whoever the teacher is, you be nice and respectful to them, okay? Be such a great character that they brag about how awesome you were. Not because you get some prize, but because of how awesome you are as a person, as a student. Okay? As I say every day, and I say it even in this video, all of you are loved, valued, cherished, respected, appreciated. I think you're amazing. I'm glad that you came to school today. And if you didn't go to school today, I'm glad that you're watching this video at whatever point that you're watching this video. Have yourself a fantastic day. Choose your success. Do the right thing. Make mom and dad proud. But remember, if you don't do it for them, do it for your future. Be the change. I plan to be there tomorrow. Have a great day, y'all. If you have any questions, don't panic. I will be back. It is okay. Again, have a great day. Play and pause this video as much as you need to. This will be posted in Schoology as well.